Hello, grade 8s. In today's lesson, we're going to begin a new unit of study, this one dealing with probability. And our learning outcome for the entire unit is to solve problems involving the probability of independent events. So let's start off with the definition of probability. Probability is defined as the likelihood or chance of a specific event occurring. And I'm going to immediately give an equation we can use to calculate the probability of a specific event occurring. And the equation we can use to calculate it looks like this. So we have P and then in brackets A. So capital P is an abbreviation for probability. And then typically the notation we use is inside the brackets, we want to identify the event that we want to actually occur. So right here, this would mean the probability of event A occurring. This is equal to the number of favorable outcomes divided by the total number of possible outcomes. If we wanted to, we could abbreviate that equation by writing favorable outcomes as FO and possible outcomes as PO. So the probability of event A occurring would be FO over PO. Favorable outcomes over your possible outcomes. Okay, let's do some simple calculations just to utilize a probability equation. So example 1, part A, says what's the probability of flipping a coin and landing on heads? Okay, now, I should clarify here that, I'm just going to pull a pen out. Possible outcomes means it's all the different outcomes that are possible in whatever experiment you're performing. So if you flip a coin, there's only two possible outcomes. You can either flip heads or you can flip tails, okay? So you get one of those two outcomes. So in the case of flipping a coin, your total number of possible outcomes would be 2. It's either heads or it's going to be tails. Now, favorable outcomes identifies the outcome that you want to actually occur. So the outcome that I want to occur is I want to land on heads. There's only one way you can actually obtain that. So if I write down the probability equation, I can write down, now to be more specific here. So I have probability of flipping a coin and getting heads. So again, in the brackets, you identify the outcome that you want to occur, and that's equal to your number of favorable outcomes over your possible outcomes. Now, the number of favorable outcomes is 1. There's only 1 heads you can actually obtain. The number of possible outcomes are 2, because when you flip a coin, you can either land on heads or you can land on tails. Therefore, the probability of flipping a coin and landing on heads would be equal to, as a fraction, 1 divided by 2. How about drawing a diamond from a standard deck of cards? Okay, so we can write down our equation. The probability of drawing a diamond from a standard deck of cards is equal to favorable outcomes over possible outcomes. In a standard deck of cards, if you remove the jokers, there are 52 possible outcomes. In a deck of cards, you have, I believe what they're called, I want to say suites, something like that. And there's 4 of them. There's diamonds, there's hearts, there's clubs, and there's spades. So the 52 cards you have, all your cards can fit into one of those 4 categories: diamonds, hearts, spades, or clubs. Therefore, you would have 13 from each one of those suites or suits. I really should know what the correct name is or how to pronounce it correctly. So in this case, the probability of drawing a diamond from a standard deck of cards would be equal to, well, there's 52 possible outcomes because you have 52 total cards, and the number of cards that would have a diamond on it would be 13. So you'd have like the ace of diamonds, like 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you'd have jack, queen, and then your king. So that would make up all the different cards you'd have attached to a diamond. So 13 over 52. A few notes. So when we did our probability calculations on the previous slide, we expressed probability as a fraction. However, it's a lot more common to express probability specifically as a percentage. Now, to go from a fraction to a percentage, we first need to take the fraction and turn it into a decimal, and then turn it into a percentage afterwards. Now, as a quick recall as to how to do that, to take a fraction and turn it into a decimal, you just simply take the numerator of the fraction and divide by the denominator. And then to take the decimal and turn it into a percentage, you would then multiply the decimal by 100, which is the exact same thing as moving the decimal point 2 units to the right. Okay, so let's do an example of this where we're going to express probability as a fraction, decimal, and a percent. So it says a 6-sided die is rolled. Calculate the probability of obtaining at least a 2 on the die. Okay, so we've got some funky language going on here. But first of all, just write down all the different possible outcomes we could have. If it's a 6-sided die and you roll it, you can either land on a 1, you can land on a 2, you can land on a 3, you can land on a 4, you can land on a 5, or you can land on a 6. Now, this word at least a 2 means that the lowest number that would be acceptable for you to have would be a 2. So if I actually circle the numbers that would actually fit into the description of what at least 2 is, and I'll do this with a different color. So at least 2 means it's the lowest number you're allowed to have. Anything above that is okay, including that. So 2, 3, 4, 5, and 6 would all be a number that is at least 2. So if I really wanted to translate that phrase at least 2 into something else mathematically, I could say that obtaining at least 2 is the same thing as obtaining greater than or equal to 2 on the die. So the number of favorable outcomes in that situation would be 5. So let's break down the probability equation. Okay, so I'm going to go back to my red felt here. Okay, yeah, let's go back to the red. Okay, so what I would say here is, so the probability of obtaining a number that is at least 2 is greater than or equal to 2 on the die. So I'd say greater than or equal to 2. So I have that greater than sign, and the underline underneath means equal to. Greater than or equal to 2 would then be equal to the number of favorable outcomes divided by the number of possible outcomes. Okay, we fill this in. Total number of possible outcomes are 6, because you could roll the die and get 1, 2, 3, 4, 5, or 6. Favorable outcomes means the number of outcomes that you want to get. So at least 2 means greater than or equal to 2. So 2, 3, 4, 5, and 6 are acceptable. Therefore, there are 5 possible outcomes that are favorable for me. Now, if we plug this into our calculator, we're actually going to get a repeating decimal number. So again, 5 fraction 6 means 5 divided by 6. So you plug that in, you get 0.83333, etc. Now, we need to round this. So what I would do for my rounding, and I'll go to another pen color, is, so for my rounding, I would try to round this to the nearest thousandth of a decimal place. So the nearest thousandth of a decimal place would be the first 3 decimals. So I want to round it to here. Okay. Now, to round this, I'm going to look at the number that follows the thousandth position and determine whether or not I'm going to round the digit in the thousandths or not. Okay, so the question is, like, do you round this digit or not? And if you look at it, 0.833, if the following digit is a 3, then you do not round that number up, okay? Only if the following digit would be a number 5 through 9 would you actually round it up to a 4, so we're not going to do anything there. Okay, so let's go back to the regular ink color. Okay, so if I rounded this to the nearest thousandth, it'd be 0.833. And then to turn this into a percentage, you can multiply this number by 1,000, or you just simply move the decimal spot 1, 2 units to the right. And if I did that, this would then give me 83.3. Okay, so that'd be the probability of rolling a six-sided die and obtaining a number on the die that is at least 2. A few other notes. 2 events are said to be independent if the outcome of one event, so event number 1, has no effect on the outcome of another one. And this is something we're going to do. We're going to combine different events and determine the probability of an event on, or an outcome on event 1 occurring and an outcome on event 2 occurring. So, for example, an example of 2 independent events would be flipping a coin and rolling a die. If you flipped a coin and obtained heads on the coin, that would have absolutely no influence on what number you would obtain on the die. Okay? Because flipping a coin has no influence on that, we say those 2 events are independent. Now, if the outcome of one event had an influence on another one, then we call them dependent. So an example of that might be you draw a card from a standard deck of 52 cards, but then you don't replace that card before you do a second draw. So when you do the second draw, you'd actually have 51 cards to choose from instead of the initial 51 cards to choose from instead of the initial 52. So removing that card actually would have an effect on the outcome of your second draw. Now, we're not going to worry about dependent events in terms of probability because it makes the calculations a little bit more complicated. So we're just going to stick to dealing with events that are independent. 3, a sample space is a list of all possible outcomes of a probability experiment. So for example, let's say we actually did the 2 outcomes listed above. So we flipped a coin and then we rolled a die. So if you flip a coin, there's 2 possible outcomes. You can either obtain heads or you can obtain tails. It's going to be one or the other. Or if you roll a die, there are 6 possible outcomes. You have 1, 2, 3, 4, 5, and then 6. Okay, so what a sample space would do is it would list all possible combinations of flipping a coin and then rolling a die. The way we show a sample space is we show the outcome in a set of brackets and then separate it from other outcomes with a comma. So for example, in brackets here, we have H comma 1. That would mean you flipped heads and you rolled a 1. H2 would be you flipped heads and rolled a 2. H3 would be flipped heads and rolled a 3. T1 would be you flipped tails and rolled a 1. T6 would be you flipped heads and you rolled a 6. So those are all the different possible outcomes you could have if you flipped a coin and then rolled a 6-sided die. So there's 12 of those in total. Now, that's not the best way to express all the different possible outcomes. It's more common and more convenient to express outcomes in a probability experiment by using more of like a visual representation. And the visuals we like to use are either tables or tree diagrams, which I'll illustrate in the example that's going to come up right now. Okay, so we have a student flips a coin and then rolls a 4-sided die. And what I want to do is I want to first of all draw a table to represent the sample space. And then I want to draw a tree diagram to represent the sample space, then list the sample space, and then do a bunch of probability calculations. Okay, so first of all, if you're wondering what a 4-sided die looks like, a 4-sided die is kind of like a pyramid, except it just has a triangular base to it instead of a rectangular base. So that might look like, here's my triangular base. And if you go to every single vertex of the base and kind of just draw lines in the vertex and then meet somewhere up at the top, like an apex at the top right here, that's what a 4-sided die would look like. Okay, so let's do a table to represent the sample space. Okay, so the way I would draw a table is I'd start off by first of all listing the name of like one of the outcomes. So for example, like event number 1 would be flipping the coin. Okay, so we have the coin here. And then I'm going to list the 2 possible outcomes of flipping a coin. So you can either land on heads or you can land on tails, one of those 2 outcomes. I'm going to draw a little vertical line here. And I'm going to draw another horizontal line here to kind of like set the table up. Okay, now these are going to represent, so the coin's going to represent the rows in the table. Let's do one more vertical line actually here. Let's do one at this location. Okay, now we're going to write the name of the second event. So the second event is going to be rolling that die. And rolling that die has the outcomes 1, 2, 3, 4, 5, and 6. Now, the way to complete the table would simply just be to match up the outcomes in the rows with the outcomes in the columns. So for example, like one outcome here would be heads, comma, 1. Another outcome here would be heads, comma, 2, heads, comma, 3, heads, comma, 4, heads, comma, 5, heads, comma, 6. I could make the table look more fancy than this, but this is good enough for illustrating the point. Okay, and then the second row matched up with these numbers in the columns. You'd have tails, comma, 1, you'd have tails, comma, 2, you'd have tails, comma, 3, and you'd have tails, comma, 4. I just realized we're rolling a 4-sided die, so actually we can get rid of those like last 2 table entries there. We shouldn't have them. So let's erase these 2. Yeah, because we're not doing a 6-sided die. We're just doing a 4-sided die. Okay, so let's put the go back and just draw that line here. Okay, those are all my different outcomes. So that's a table. Now, a tree diagram, which I personally find is a little bit easier to draw compared to like drawing a table. So what I would do is write the name of the 2 events. So the 2 events you have is you can flip a coin and you can roll the die. And we can underline these. Okay, so for the coin, there's 2 possible outcomes. So again, we have heads, and then we have tails. These are going to be like the trunks of 2 trees. And then what we're going to do is we're going to draw branches from these trunks that match up with the outcomes on the die. So here, you'd have like heads, and then 1. And you'd have like heads and 2, heads 3, heads 4. And then over here, you'd have tails 1, tails 2, tails 3, and then you'd have tails and 4. Okay, so whether it's the table or it's a tree diagram, it shows all the different possible outcomes. And the total number of possible outcomes would be 8. You can determine that by counting the number of table entries. So you have 1, 2, 3, 4, 5, 6, 7, 8. Or count the total number of branches in the tree. So you have 1, 2, 3, 4, 5, 6, 7, 8. C wants me to list this as a sample space. So again, a sample space also shows the possible outcomes, but it's just a lot more tedious to like write them all down. So this would be, and it's not really visual. So you'd have like H comma 1. You'd have H comma 2. Again, you're writing your outcome in brackets and then separating the different outcomes with commas. Okay, we could go on to another line here, because otherwise I'm going to run into my tree diagram. So tails 1, tails 2, tails 3, and then tails and 4. Okay, so 3 ways of showing all your different outcomes. You have a table, you have a tree diagram, and you also have a sample space. Okay, now we're going to start to do some probability calculations. So D says calculate the probability of flipping heads and then rolling a 4. Okay, so what I'd probably want to, let's write down the equation first. I'm going to go into the next slide here because I've run out of space. Okay, so we'll go up here and write down, whoops. Okay, so let's go here, do D. Okay, and we're going to say the probability of And what are we doing again? We're flipping heads and rolling a 4. So the outcome I want is probability of getting heads, comma, 4. Okay, that would be equal to your number of favorable outcomes divided by your number of possible outcomes. If we go back to this picture here, so total number of possible outcomes is 8. Okay, we've identified that whether you look at the table entries, you look at the number of branches on the tree, or look at the number of brackets you would have, open and closed brackets you'd have for the sample space. Now, how many ways can you actually get heads and then roll a 4? Well, we can look at this. So I'm going to choose a different color just to highlight it. So let's go with green here. There's only one way you can do this. Okay, you can get heads, comma, 4 here. You could get heads, comma, 4 right there, or you could get heads, comma, 4 right there. So there's only one way you can actually obtain heads and then 4. Okay, so let's go back to our calculation now. So this would be 1 over 8. Now to turn it to a decimal, 1 divided by 8 would be 0.125. And then to turn this from a decimal to a percentage, move that decimal spot 1, 2 units towards the right. So you'd have 12.5%. Okay, the second one calculation wants us to flip tails and then roll an even number. So let's go here and we're going to write down probability of flipping tails, then rolling an even number. Okay, that's going to be equal to the number of favorable outcomes over the number of possible outcomes. Okay, our possible outcomes are not going to change here. So favorable outcomes, let's identify this. So let's pick a different color now. Let's figure out how many possible ways can I get tails and then an even number. So let's choose the ink color purple here. Okay, so we're going to focus on the tails part of the table. So tails and an even number would be tails and 2, or would be tails and 4. So there's actually only 2 ways you can obtain that. Or if you looked at the tree diagram, it would be tails and 2, or it would be tails and 4. Or the sample space would be tails and 2, and it would be tails and 4. So once again, only 2 ways you can actually get that. Okay, let's go back to the red ink color. So this would be 2 divided by 8. If you want to, you could reduce that fraction, but you don't really need to do that right now. I've done enough work with fractions in the previous unit. So 2 divided by 8 would be 0.25. And then you turn that to a percentage, multiply by 100, or move the decimal spot 1, 2 units to the right, and then you have 25%. Okay, the final one says calculate the probability of flipping heads and then rolling at most a 3. Okay, so we've got that funky language going on here again. Okay, so let's try to clarify what this actually means. Okay, so at most a 3. At most a 3 means that is the biggest number you're allowed to have. So at most a 3, so would mean you can have any number that is less than or equal to 3. Okay. At most means that's the biggest number you can have, which means that's the same thing as less than or equal to that same number. Okay, so let's go and set up our equation, and we'll come back and identify all the different favorable outcomes. Okay, so we're going to write down the probability of, we want to flip heads, so heads, and then, comma, we want to get a number that is less than or equal to 3. That's at most 3. And that's equal to favorable outcomes, FO, divided by PO. Still have 8 possible outcomes. Now let's figure out what the favorable outcomes are. Okay, so let's actually highlight this in the blue color. Okay, so heads and a number that's less than or equal to 3. So that could be heads and 1, that could be heads and 2, that could be heads and 3. Okay, less than or equal to 3. We could circle out a table, we could circle that on the tree diagram. Heads and 1. It's getting super messy now. Heads and 2, heads and 3. It's not necessary to actually do this, by the way, to actually circle the favorable outcomes. If it helps you keep track, though, then by all means go ahead. So heads 1, heads 2, heads and 3. So there's 3 favorable outcomes. Okay, so let's just calculate that. So 3 favorable outcomes. And plug that into a calculator. And yeah, you could do the long division, but again, let's not focus on that right now. The emphasis is mainly on doing the calculations. So plugging into a calculator is fine here. 3 over 8 would be 0.375. And if you multiply by 100, that would give you 37.5%. It's much easier to determine a percentage if the decimal number you calculate is not a repeating decimal. Okay, it's much more annoying if it's repeating, because then you have to worry about it rounding. All right, so that's it for this lesson. And what you can do is complete the assignment called Probability of Independent Events, Part 1. And that's an assignment in the probability workbooklet. And then the next lesson, we'll just continue with more problems dealing with the probability of independent events. And I'll talk to you then.